Google Translate in 2017 or something. Basically, like, it's a layer of a network that, like, when it's trained correctly, so you put in like a Spanish sentence. So you put in a Spanish sentence.
Let's get started, guys. I'm glad you could all make
So like
it
how
tonight
connected each other is. Nice.
on this wonderful January evening. It's actually my birthday, so we get to have my favorite meetup on my birthday.
Mine too.
It's your birthday too?
Happy birthday.
Oh, happy birthday. I'm glad we both have the same idea of what is fun to do for your birthday.
Well, who's got the German version of the coding?
The IntelliJ, because normally
You
it's,
want that?
no, but I've already got one, but it wasn't my birthday.
No, I didn't print one either because I've just been off. I didn't work today. I took the day off and came in, and so I didn't print it off because there's no printer at my house. So I never need to print anything at my house. But if you want to remind, what's your name?
Cameron.
Cameron, are you on Slack? Okay, I'll get you. You can have a year of JetBrains for your birthday. I'll send it to you. Just remember, it was Ed's idea.
Happy birthday.
So,
I hope they mention it's my birthday as well.
I'll see if I have a backup. Okay. I just wanted to let everyone know we do have a Slack community that is mostly consumed by people talking about Kubernetes, but the link is on the Meetup homepage. So if you go to the Meetup homepage, there's a cool little link that will invite you to the Slack. If it doesn't work, let me know and I can send you an email. I post a bunch of stuff about machine learning occasionally. I go on spamming spree, so I'll just post a ton of stuff one day and then wait a week, and post a ton of stuff another day and then wait a week.
Catching, I appreciate that.
But I pretend to post a lot about machine learning on there and data stuff and all the cools. Yeah, I don't think next month we're gonna have a cool talk about data engineering from Joe Reese. Yeah, Joe Reese and Matt Housley. They are yeah. They got me to do a talk for them, so I said, now they get to do a talk for me. Swift. They organized 3 meetups, I do 3 meetups, so we switched. So yeah, that's all I've got.
The Go conference.
Do you think people here care about my Go conference?
I do.
Justin cares about my Go conference, so I'll let you all know. I and a co-organizer named Derek, we are planning a Go conference for this May. It'll be in the Jordan Commons Megaplex in Sandy. One-day conference with workshops the day before if anyone's interested in the Go programming language. It'll be super awesome. I'm not speaking, so there's no Go ML. Sorry. You can look me up on YouTube if you want Go ML. It's a great conference. Forge Utah that sponsors this meetup is also, I work for Forge / whatever the nonprofit. I'm a director on the Forge Utah for the Forge Utah nonprofit. They sponsor the meetups and they're doing the conference, so that's how that applies. And they also do the Slack, so basically everything's on Slack. We have a jobs channel on Slack if anybody's looking for a job or has a job to post. That's usually where I direct them, just to kind of keep clutter out of here, but also whatever. I'm going to turn the time over to Ryan, though. He can introduce himself if he wants to say anything fancy. But other than that, the time's yours.
All right.
And we'll just give you a hand to start off.
I mean, on that note, too, about jobs, you'll find out. I work for Micron. It's a global company, so if any of you are interested in moving, mainly to Singapore, there's lots and lots of jobs. There's
You're moving to Singapore?
I'm not moving to Singapore.
Oh,
I'm staying here. But no, there's lots of data science jobs for our company. There's a lot of push there.
In Singapore.
In Singapore. Well, yeah, it's a global company. So I'll start out telling you about me. I made an about me slide. I feel like 6th grade again. So about me, I'm not a traditional, I don't come from a computer science background, I just come from an engineering background. And I was actually in the Navy for about 6.5 years before I got back into this civilian world. So I tell people I was in the Navy. I want people to think that that's me behind that 50 caliber machine gun firing off that ship right there. But in reality, this is about what my job was in the Navy, actually. I was an instructor in the nuclear power world. So sailors who were to operate nuclear reactors, I was part of that training, helped them learn what they need to do so they didn't go melt down a reactor. So taught a course in nuclear physics, did a course for systems engineering, and then I did some program management for the whole training program. So that was fun. But then I decided, I really want to kind of get back and stop being such a liaison, because it's kind of what you are in the Navy, and do something a little bit more hard engineering. And so got a job at what was used to be Flash, just up the hill here, right? Intel Micron joint venture. Then just later last year, there was a little breakup between Intel and Micron. They decided that they didn't like each other very much anymore. Really, it was a good change in how the direction of the company was going. We've got a product I'll talk a little bit about here, and they had some different ideas about that product. But so now, just work for Micron. I started there in the process control, automatic process control. I don't know if anybody's here in an industrial world. Maybe process control, automatic. So I thought maybe our Sinclair guy, maybe has a little bit of idea about it. But so yeah, process automation, did a lot of that. So I am passionate about automating everything I can, and that is really what turned me towards data science. Not to mention everything you go to school for automatic process control also applies to everything in machine learning. So it was a really easy transition for myself. But in terms of education-wise, did my undergrad here at the U in medical imaging, and then did a master's at Purdue in automatic process control, which is hopefully how I got started here. So that's enough about me. So a little bit about Micron in general. So Micron, we're a semiconductor manufacturer. We make memory. And as data people, this is pretty good stuff. The product we make here in Lehigh specifically is called 3D Crosspoint. Has anyone heard that buzzword floating around? Maybe Intel Optane even, maybe? Okay, so this is a brand new technology that's very early still in its stages. It's being marketed. Micron just last year came out with this product, this solid state device called the X100. It blows any other solid state device out of the water right now in terms of memory. Even Intel's competitive Optane drive as well. It's pretty awesome. But the cool thing about this is this technology. Again, I'm not going to geek out a little bit, but this sits between like DRAM and NAND flash in terms of speed, right? So it can be up to 1,000 times faster than your NAND flash memory, which is your standard SSD, but higher densities, and it's non-volatile compared to DRAM. So there will be a day when you just turn your computer on, it's on. It's always on or off, right? There's no difference between those states. The data ingestion is huge as well. I like coming from having a little bit of medical imaging background. Technology like this will take, I just actually had an MRI recently. We had a car accident last month. Take that 1 hour MRI I had to sit through down to like 4 minutes, right? Because just in terms of the data ingestion, right? So this is where sounds kind of prophetic, but this is where the future's heading in terms of what we're doing, right? So this is cool stuff. I find it very interesting. I'm pretty excited to be part of this, actually, be part of this data-driven culture that I do for my job. So now let's get to the heart of this. So the topic of today is about human-in-the-loop systems, really, and how they can be applied to machine learning. Just by show of hands, though, how many people are working right now on some sort of data science team? Or support a data science team in some way, shape, or form? Okay, so about half of us, that's good. So in my experience, you've only got about a handful of problems usually in a company that are these big, huge, million-plus example data label type problems that you can solve, right? Where you can solve a ton of problems with still this giant data set that you're working with. Now, there's a few of those. I'm talking like very large, right? That you can throw a whole team at and you can really get some value. But they're usually long-term projects, right? The realization of value is usually on the timeline is usually on the order of years. What I found and what my team has found is we find a lot of really, really good solutions in these what I call small data problems, right? Where we're working at there's problems that you didn't even think they needed to be solved, but customers are coming to you with their specific use case. They've got maybe 10, 15 examples of what it is they're trying to solve, and they want you to help them figure this thing out, right? So classic case of this is going to be, right, you have this very small data set, very imbalanced data sets, and there also might be a little room of error because maybe it's an anomaly detection type of problem. All right, so this is kind of where we're headed today, and how hopefully you can see how by incorporating kind of a feedback loop with your customers in part of this, that you can actually improve and solve these types of problems with a lot of success. So this is, as I don't know if you guys know Tyler Folkman, I know this guy, I've launched him a couple of times. I like this quote, he just recently put it up on LinkedIn about 5 days ago. I think I pasted this in last night. Again, I think where we're headed as a data science community is trying to find better ways to deal with small data. And I mean, again, we're talking still maybe thousands of examples, but still thousands of examples is still maybe not enough in certain cases to really solve your problem. So hopefully this is very applicable to where things are going with the data science community in general. There's my disclaimer. This is an algorithm agnostic talk. I'm not talking here to talk about algorithms. I'm actually here to talk about more of design principles and getting people involved in part of that. I'm very passionate about that. I feel that data science is very, very bleak if all you're doing is sitting in a silo and coding away on some data set that no one really cares about. Right? We want to solve problems that people actually care about. This is not a silver bullet to success per se, and it may not apply to your business model. I don't know what your business use cases are, but in our case, our company's case, my team's case, we've found a lot of success with this. So, where we're headed. So, we'll talk a little bit about just generally what I mean by human in the loop. This might be a new concept to some. It's a generic term. And then talk about what a human in the loop architecture for machine learning or artificial intelligence would look like. And really kind of round it off with applying this to small data. So, and hopefully this is a discussion. Please ask questions, interrupt me. I'm not going to get offended. I really want this to kind of be open and so we can have a little bit of talk around it. So, with that, I think a lot of times when, again, going back to my anecdotal experience here, when you're trying to solve these problems, we oftentimes just say, here's a data set, or someone comes to and said, here, go look at this data and go solve this problem for me. Okay. But I think at this point, we begin to start disconnecting ourselves as humans from this learning process. That's what's happening, right? We look at what machine learning is. What it's trying to do is we're trying to take some sort of task that we can do really well as humans, or maybe even a task that we can't do really well, but we have an idea or intuition about it, and we're trying to transfer that. We're trying to get something out of that from this machine learning model. So again, it's not all about algorithms. In fact, you can solve really, really, really complex problems with very, very simple algorithms. So there's a lot of it, right? It's about the data and the people that are involved with these problems. Yeah. And just an example just came to mind, but really I found again that you're gonna find that the best results you're gonna get in working with in data science in general are gonna be from problems you didn't think you needed to solve, because they're not gonna come from you. I really hope that those of you who are working on data science teams, your job is not, here, you're a data scientist or you're a data engineer, you're this or that, go solve these problems for me. What problems? Well, I don't know, just go solve some problems. Go make some value for our company, right? I feel that sometimes this is happening. Well, in reality, it's find out and work ways to build trust with those in the company, and I think this is a way to do that. So, how many people know this example here? This guy, this is a fun one, right? So data complexity. I like this as a data complexity because it wasn't a big data problem. It was actually a really small data problem. So Abraham Wald, he was part of the statistical research group in Columbia during World War II. Navy, working for the Navy. Oh, again, kind of dear to my heart here. But this is a survival bias problem. And the problem was, how do we ensure that more planes make it back from coming back from war? So the goal was, okay, we need to reinforce parts of the plane. We need to up the armor in parts of the plane that are going to cause the plane to crash, right? So what they did is they said, okay, let's look at all of the planes that are returned back. Let's map out where the planes have been shot, and we'll calculate some statistics about how many bullet holes per square foot on the plane there were, and those ones that are the highest, yeah, that's where we're going to stick more armor, because that's where we're getting hit a lot. And so who knows what was the real issue to the problem? What was the solution, really?
The ones that got hit where it actually mattered were not, I mean, they didn't make it back, so they never saw it.
They weren't in the data set, right? Right, the data set excluded all of the important data, okay? The planes that obviously were making it back, these survived. So the point was, you put the armor where there's not bullet holes in your data set, right? And that's gonna help you improve your survivability. It makes sense, right? You get hit in the cockpit, you're gonna die, probably. You hit on these parts of the wings of the front here, possibly cause engine failure, you're gonna die, right? There's a gunner back here, and right, so you might lose your tail fin if you get hit enough back here, so then you die, right? So again, data can be complex even though it's not big. Data can be complex in a lot of ways. And so again, by bringing, so for instance, in Abram Wald's case, he was an outsider, and you bring a bunch of Navy, US officers who thought that they knew what the solution was, bring them together, right? You can start seeing some more insights into your data, bringing people together. That's the point there. This is a great quote. Did a course in my master's degree on complexity, it was, or not the course, but there was a topic in one of my courses on complexity, and I really like this. So it applies when you're talking again about mixing these things. So complexity is the study of the phenomena which emerge from a collection of interacting objects. Our case, right, data science might just be, it's more than just the data. It is the interacting objects of all of us trying to solve whatever that problem is. So, all right, so human loop system, what it is. So this is a fun example that's near and dear to my heart as a control engineer. This comes from a paper that was showing about designing a device that would help you walk. Right, so it was designed for a control system that would help you walk if you had issues walking. So if you look at figure 8 here in this diagram, you've got a couple of loops going on here. You see the human and the device loop, right? So that's your basic control loop where the human's walking, and this device's job is to maintain the right amount of torque on the device to keep the human upright. But there's an additional performance measure here. And so this device is also looking at the metabolic rate based on what chemicals are in the person's breath as they breathe to see, okay, how much energy are they expending? And over time, you would expect the person as they walk to expend more and more energy. And so what this does is it optimizes the control law, just think hyperparameters if for machine learning cases, right? Optimizes the control law and gets you a better result. Again, this is a good example of a generic case of what a human loop system would be. You could just have this first little loop here between the human and the device, and it would provide torque, and it would provide the same amount of torque all the time. But with this additional measure, you get more value out of the system. So moving to now machine learning case. So if we look at kind of a standard machine learning type process flow, this would what would be where a human in the loop system would be. So in this case, we have some classifier model. It's sending out classification predictions for which it's confident. That's hitting the output there. Usually, when we're talking about supervised learning, you've got some human annotating a bunch of data for you, or something is annotating a bunch of data for you and putting that out as an output as well. Any uncertainty that's in the system should be fed back to the human. Look at it again, and then you have this little space here called active learning, right? And this is where this is getting at the heart of what we're talking about, is that now between the classifier and the human annotation part, you can create this model can learn over time. And the great thing about this whole model in general, not the classifier model, but this model feedback system, is this requires human interaction. There's a human that has to be plugged into this, right? And it's more than just that data scientist or whoever that built that classifier. It's that human annotation comes from the data expert. So I think in very few instances, if you work on a data science team, do you work with data where you are truly the expert of that data? I know I don't. I work with a lot of different customers who they look at that data a lot more than I do because they deal with it on a daily basis. I might deal with it because I'm here to help them solve a problem that they can't solve on their own, potentially. But they're the true experts. And by putting them in this loop, by putting them part of the system, rather than just be like, okay, hey, I want a data, like I'm gonna help solve the problem, just give me this data set, just throw it in this filer over here. I'll pick it up, I'll run some models on it, maybe put it through this auto ML thing or whatever it might be, and I'll let you know what I find out. Right, instead, we're gonna talk about how do you really get them more involved in this. And a lot of it surrounds automation, surprise, surprise. So the catch here is really, you just can't make this too hard. People want to solve their problem. They also don't want it to be hard. How many of you have actually labeled a bunch of data before? Actually done that? Is that a fun task to do?
It can be rewarding.
It can be rewarding. Expound on that. Please expound on what you mean by rewarding.
Well, because the work you put into it, often you get back in the generalization of the model or the F-score, whichever.
Awesome. So you, in this case, this instance, maybe one of the instances, were you also the expert of the data as well? So
I became the expert.
right. Yeah. That's and it
I
happened
wasn't at first.
You weren't there at first.
I wasn't at first.
Yeah.
Yeah.
So you were working with somebody, I'm guessing, or
Someone had an idea and they said, hey, what if we're able to classify these images, these old ancient Chinese images?
and then
Yeah, and then it was, well, what do you mean? And then it became a really, really big problem and really gnarly.
yeah.
And then we started learning together. Actually, that turns out that person wasn't the expert either.
They start really good. Wow, I'm outside of my depth of knowledge there, or what?
Yeah. Yeah.
Did you get an expert, or did you guys just become because of the?
We became the experts. We brought in certain people that were experts in a certain area. Does this make sense? And yeah, it was about 6 months worth of labeling.
Yeah. Wow. Yeah. See, but it was rewarding. So at the end, it worked. Whatever you want to do, it worked for you.
Yeah.
That's really cool. That's a cool story, right? So, this is real, right? That you look at that example. That's great because it shows again. You might certainly solve a problem. Labeling images is definitely. I've been there doing it still, right? It's horrible to some degree, but there can be great reward, right? And the easier you can make that data collection process, the easier you can make any part of this loop easier for you, the quicker you'll get to that reward. And the outcome is, you have a higher likelihood of having an outcome that you find satisfactory. Something's going to meet your demands versus something that, wow, we just wasted. Because it would have been terrible if after 6 months you're like, nothing worked. Yeah. This is horrible. Yeah, and that happens. That really does happen. So to get to that failure as fast as possible, or to get to success as fast as possible, there's kind of the key here. So hopefully this kind of makes sense. So just again, this is very generic. This is gonna change or be different based on who or what the problem is, your business or whatever. But to me, when you're looking at these human loop architecture systems, you've got there's four parts to this, and it's very simple. It shouldn't jump out as a surprise to anybody. But we're going to talk about each one of these and what I think, and from my experience, what I think is important. And if you've got other things, I'd like you to definitely add on to here. So starting with one of the most important parts that I think, so there's two most important parts, and I'll start with this one, is your data feed. So at any time you're starting to work on a problem, you need to ask yourself, how will new data be collected? I'm not talking about the data that someone's going to give you initially. But how will this data keep coming in? Because I'm assuming, maybe with your example, is data coming in all the time? Is there some kind of feed that's occurring? Yeah. So that needs to be answered. That question needs to be answered. Like, how do I get new data? And how can I automate that process? How do I get that in an automated fashion? So I don't have to go through, dig through a bunch of Excel spreadsheets, if that's how someone's doing some business, or heaven forbid, some MS Access database. And that's not right. Very, very different. I had to do that. That's why I say it. Okay. Horrible. It was fun. But you want to automate that. I still did. So in this example, right, someone had an MS Access database where they were keeping everything. I get new data. I got to get snapshots of this database. And it's SQL, right? But it took some special drivers to be able to do what I needed to do to be able to then automate the process. But I did that because it's important. Because I didn't want to have to every week go through, run a SQL command, output that to some file, and deal with that. I wanted to automate that, so make it easy. So I took that, put it, and then I put it into another SQL database that I wanted to deal with. So again, how will you store it, right? So another question is, how is it going to come in? And that really kind of depends on the data type. Is it should it be relational data? Should it be NoSQL data? Does it have to live in the cloud based on what my business needs are? Or can it not live in the cloud because it's too proprietary and I'm too worried about it? Those types of things. And then another question is, if I'm going to build a model for this thing, if this data, if the end result for this data is to be used for some kind of inference engine, how am I going to interface with the model? How does the new data stream in? At what frequency? At what rate? Does it come in real time or near real time? Does it come in as a batch? How does it work? All right. And so, yeah, go ahead.
How does it interface the model at training time or inference time? Both.
Great questions. Yeah. So, right. How does it interface with training time? Okay. And we'll talk a little bit about that because the active learning
training time is all the time if this loop's really tight, right?
Right. Depending on, right. That's good. Yeah. So we'll kind of expound on that. But yeah, think about that. How often does it need to be retrained? What frequency? How long does it take to get a result, right? Is this a very big deep learning model where I have to have a lot of compute to actually get a result out of it? Or are they super small, fast, nimble things that I can actually do in parallel? I parallelize this, put it somewhere else, right? And if you're not the expert, you might require I just said data engineers here, it could require any type of person who's just familiar with what it is you're trying to do. And that might be you too. So this is the next important part, the interface part. So I'm going to go back to your example, if that's okay. Now you volunteered this up. How did you, when you were getting the images of these Chinese characters?
Genealogical books.
Very cool. So how did those get, did they just get dumped in a filer somewhere or?
No, it wasn't that easy.
Okay, yeah. So, right, so that was going back to the problem here, right? How do I store it, right? How did you store that?
Well, it was already stored in a system that was just meant to display the images.
Okay.
And people were meant just to kind of look over them manually and figure out what it was.
Okay.
And then there was a separate system that then said, these are the important images. And then what we were trying to do is figure out, there was a separate system that said, there are important parts of these 2,000 image sections of this book, and there's 4 important parts. And our model had to figure out where the important parts started and ended.
Very cool.
But originally it was just stored up as these big, huge images, and we couldn't run that through. The neural nets aren't exactly fast.
Right.
So we first had to do all sorts of normalization on the images and make them smaller so we could run them through. And it turns out that the data, guess what? And it's big data, as we're talking, billions of images.
Yeah.
So it turns out that the images aren't always in good shape, and sometimes they aren't even always there.
Yeah. Surprise out of it, right? Yeah.
Right. And so we had, there's a whole process of just cleaning up the images and what happens when they're not there and what happens when they're not in the expected range that you'd expect them to be in and all that.
So then when you were looking at those, having to through that process, how did you view them? Would you use that software that they provided, that the service provided, or were you moving that data in somewhere else and then looking through it?
So we grab a whole document. Originally we were using it, but it was too slow because it's web-based.
Right.
And it would just show the thumbnails, and sometimes you got to drill in to see the whole image of, is this Chinese character here or not, type of thing.
Right.
And so we wrote a tool to go download it for us, like in the evenings and stuff like that. So we would have a whole set of books in the next morning, so then we can just look at and run through our model to have it do its best of predicting it and then fix the wrong parts.
I see. So then you were just looking at your file system, probably.
Right. Yeah.
So in that case, it made sense, right? It made sense to look at it in that way.
To shorten the latency.
Absolutely. Yeah. So he's got a lot of data, right?
Right.
And I mean, yeah. So again, when you talk about this human interface part, it might make sense. It might make sense to just drop everything in a filer and then just look at it in your file system. It might be easy that way. Or the data could be in such a way it's small enough that you can put it in a web interface, make it nice and pretty, however you want to do it. But this is something to be considered. So if you're dealing with, in this case, I think you obviously, the two of you were trying to solve this problem together. And a lot of the cases that I deal with, I'm helping someone solve the problem. They work in a different, obviously they do their normal job. And part of that normal job does not include dealing with the problem necessarily they're trying to solve. They deal with the problem, but they deal with it in their manual way. They don't deal with it in an automated way, but they're trying to get to that automated solution so they can free themselves up to do even more work, right? Or even more meaningful work to them. So in my experience is you're trying to make something as easy as possible when you're working with someone who's trying to solve that problem. So it should be some kind of intuitive, easy interface, and it could just be a filer. It could just be that simple. Here's all the data, bam, look at it, it's right here in this location, go look at it. Could be a web interface, could be anything like that. And it should help them, it should show them, they should be able to go through it very quickly. My goal is to make sure that whoever I'm working with, they don't have to spend more than 10 minutes a day looking at maybe the images that I need them to look at if they need to. Right? So that's kind of the max, try to maximize, optimize the value of their time and get it out as much as possible. And I'm only going to try to include the most helpful analytics, right? What I mean by this too is, this example of the Chinese books is very good, that as you really don't know what you're looking at until you start looking at it on a frequent basis. And you'll realize how dispersed the data is, how it might change with time, how it's going to, so there's drift, there's some kind of temporal component possibly that's involved with it. You might see that it's incomplete, there's lots of missing holes, there's lots of holes. You know, there's a lot of things, you don't get that until you're starting to see that data stream in. You're starting to look at it on a really frequent basis. And making that easier for whoever your customer is really going to help improve that whole experience. So any questions on that? Yes.
Just have a thought on that.
Yeah, please.
I was working on a labeling tool last year, and I found it really valuable to go and interview the people who would be using the tool. And I'd come back with a list of like 10 things to change. And then I'd do all those, and then I'd go interview a different person, and I'd have another list of 10 things to change. And then another 10 things, and then another 10, you know.
It keeps going.
Yeah. It was really fun and super valuable because by the end of it, I had a tool that was like really easy to use. And
yeah. This is great. This literally just happened before I came here. I was getting ready to kind of close up shop at work, and this is someone who's not a direct customer, but they work on the database side of things in a different department. And they came in and they wanted to come talk about, we had some questions for him. And it spiked a whole huge conversation about an interface that my colleague had built that he didn't like. It was great. It was valuable information, right? Because this individual said, well, we've already built a similar thing to look at the data, and it's like this. And we said, okay. So we started listening. It sparked this conversation of what was important to them. And obviously, I'm looking at it right from a perspective of, I want all this metadata to be labeled with this image potential. I want all these other things that are there. They don't give a crap about that extra stuff that I was doing because his goal was different. And so we were like, well, it's silly to have these different things that are out there that exist. We should probably try to marry these two products together. So it turned this conversation of how do I get new requirements, and how do I make my product work for all these different customer sets? How do I make it work with them? So yeah, I'm glad you brought that up. That happens, and that's the important part of being close to who it is you're working with and who it is that's actually providing this data for you, rather than just going taking off and running a bunch of models through it and just giving it back in some way that may not be so meaningful. And again, part of this is if you're building a predictive system, this interface should include those predictions. It should have those. They should be able to see exactly what that model's thinking. And there should possibly be a way that you can annotate that, right? That'd be nice. It's nice to see, here's the prediction. Oh, that's wrong. Change it. That's now different. All right. That's not class A, that's class B. Or that prediction is way off. There's some way I can make a comment about that so that I can go back in later and look at that. But we don't have to be together to do that. Yes, go ahead.
You ran into the problem where when it's fuzzy what you should label it as.
Yeah.
And so the original person who labeled the data, right, might have labeled it under one strategy, and then a new person comes along and starts labeling under different strategy.
Yes. Yeah, it happens, right?
Yeah.
Sorry, was there more to the question?
Well, I'm just wondering how, if you had any experience with making the UI or doing something that would mitigate that.
Yeah, That's a really good question. So yes, back to there was one model we were trying to build, and there were two people from that department that were providing the data for us. And those two disagreed about how things should be classified in certain classes. It was fun, right? So we have to oftentimes sit together in a little room, all three of us, and try to kind of like make sense of this and what makes sense. But yeah, so there definitely so. Have we incorporated this? Yeah, go ahead, Ed.
That people put their confidence in when they label something, because a lot of times you know with what confidence, yeah, it looks kind of like a 3, 5, but you know, but there's usually no way to put your confidence with what you're labeling. So
That's a really good. No, go ahead, keep going.
that's the end of it.
That's the end. That's good. That's perfect. Like, right? So you see that. You're like, yep, this is class A. And the other guy was like, no, that's.
Okay, I will embellish.
Okay.
Those are intelligence tests where you not only answer the question, but you say with what confidence. And at the end, you get a score called calibration. And it's very important to know, some people seem to be overconfident and they think they know more than they actually do. And that's a dangerous thing. So you get back this score that, not necessarily how smart you are, but how calibrated you are. You should know how smart you're not. Anyway, so that's
Yeah.
little thing.
That's really, yeah, that's perfect. So like, to kind of answer the question about that, that's been definitely something discussed. As of right now, right, labeling systems, the systems we're using, it's just whoever's, you know who made the label, and you know the comments they've made, and you know what label they put. And someone can go in there and change that if they're allowed to. So we've seen that kind of where it flips back and forth, right? So usually in those cases, we're seeing a lot of differences. It usually at that point says, okay, we need to sit down together and kind of figure this out. But I like, there's definitely ways to potentially, maybe there's something we can do to say, how confident are you, right? Can you give this kind of qualitative score of how confident you think you are in this label? Some rules of thumb that we've learned to follow is what has the most impact to the business, right? If you want to call it A and someone else wants to call it B, but A, in the case like maybe an anomaly detection problem, A causes a heck of a lot more problems than B does. Then you say let's call it A, because that's more impactful. That's something we want to see, even if it's a false positive. We still want to see it.
And that's the strategy part I was talking about. Sometimes you do that, and a new person comes on and doesn't know that's what you've done.
That's what you've done, right? And that's, yeah. And there's definitely some strategy around that with how big you make this team, or how big you're allowing, how many people you allow into this collective mind, if you will, that you're trying to, the task you're trying to create, right? We've definitely started, most projects start out with, okay, we only want like a max of 2 people who consider themselves the experts at this problem to go in and start helping with the problem. I dealt with a lot of image classifications, so a lot of image labeling in my case, but right, whoever comes in and kind of deals with that problem. So they need to be, so we start small, and then we can, as we start to feel more confident about what's going on, we'll start to kind of open up that circle of influence a little bit. Ed, you gonna say something? Okay.
It's just my resting face.
It's your resting. Like it. So, yeah, these are great things. I mean, these are things that consider real problems. There's real things that you're going to encounter when you're trying to build these types of things. And that strategy is important. And how you, again, that's the human aspect of this whole thing. And how you interact and how you deal with these types of issues where there might not be, what's the word? It's not going to be everyone's agreeing with whatever the solution is. So storage, again, this is important as well. You got to store all that data somewhere. If someone's labeling this data, you're going to put it somewhere. Again, it depends on what that data is. Maybe image data, might be just relational type data. So again, we use a myriad of different types of database systems depending on the data type it is. So my team, we just kind of put it where it makes the most sense based on the data type. If you're getting feedback, which this system should really include some sort of feedback mechanism to bring it back all together, and it should be indexed appropriately to include any of the metadata that you also find important. There was a thought that came to mind when what's your name? Christian. When you were talking, it kind of brought this up about as well that came to mind. So we had an issue too, the same problem where the class differences that drove why people were calling things differently is because the other individual who had been at the company longer, he was using the additional metadata. He knew where that image came from. He was using that additional data, right, to actually draw his conclusion. So that's another thing, right? So when you're building these types of things, you're going to start learning, oh my gosh, there's other things besides maybe just this image that tells me about this system. So if I can build a mixed model type design, if I can put a couple things together and bring it all together, this is going to help me because I'm going to get to a better conclusion. So anyway, that thought had come in right as you're talking as well. So those happen. Storage, again, include the metadata because that metadata might mean something. There might be more to that additional data that you have. And then if you don't really want to build these things, because they're not always fun, they're hard, it's not always easy to do it, then you can do, and you don't have the resources to do it. There are companies that have done some of this for you, right? These are some of them. I can't say I've used much of them. We haven't evaluated them. We're very IP concerned at Micron, so things are a little tight. But these companies, from the research I've done, they provide at least from the labeling aspect, from the feedback aspect, they have a lot of those tools here. So there are tools available to do that. So now, just kind of wrapping this home again, back to these small data problems. So this is a very common case. Again, this is all just maybe toy data, but I see this problem a lot, where you just don't, if you look at the numbers here, you just don't have a lot of data. I've got these different things I'm trying to classify potentially. There's just not a lot of them. Literally tens of examples, right, for each class. And this one happens way too often where I work, where you got a lot of examples you could care less about. And then the one thing you're trying to find that maybe has, again, maybe a few hundred examples in this data set. And the worst one is this guy, where you got, again, lots of data that comes in your stream that you just don't care about, and you've got all these other classes you're trying to predict. There's a lot of strategies that can come from this. And again, by bringing that person in the loop, you kind of have this problem. You can handle these types of things. And if you've automated your data feeds, right, you're going to be getting the odds of you catching or seeing these anomalies at least to be labeled or added to the data set increase. You've got an expert involved in the system. They're able to provide that feedback for you, and you're able to deal with those. So again, going back to the thing, the most important part, this is again about this loop. I feel that this is it, is getting the data to the user, making sure those users are seeing that data so that they understand what is actually in that data, what it actually looks like. When it comes to automating your data feeds, really try to think modular. I don't know, again, what backgrounds there are and how much programming you have, but from an engineering perspective, you want to think modular. Think microservice. Think, how can I provide quicker, easier access to data layers? I've got tons of different data. I deal with so many different types of databases. So what we try to do is simplify and make a very modular data layer in our team. Make it very simple to be able to get to this data and that data and bring it together so that it's output easy for the user, even though they live in completely separate data worlds. And then, again, don't rely on your customer to always be bringing you the data. They'll run out of steam really fast. 6 months of data labeling, they'll run out of steam really fast. They're constantly having to also be part of that process of gathering that data, automate that feed, figure out how to make it easy for them. So all that they're doing is providing their expertise. They're seeing how that data is coming through. Just make it easy. This is where you really you bring that value, right? So you get that automated data delivery, you get a high level of customer engagement with that. You're going to spend more time, right, on the data complexity. So kind of going back to these types of problems again, looking at this, because you set up something like this, you're going to be able to handle that a lot better because you're going to be able to spend the time while you're understanding that data, doing things like you're going to spend some time actually knowing what features actually matter in this data. What can I kind of distill down to actually get value there? That's a common step. We pretty much do that in all of our times. But how much time do we actually spend on data augmentation? How many of you actually have used data augmentation techniques for not just images, but for anything else too as well? Images is really easy. Yeah, right? You've got to find ways to make one example potentially sometimes look like 10 examples. Right, so depending on how your model is built, this is very model dependent. But again, if you've got this fairly simple, here's my little toy example here. If you're your classifier is finding bad apples, right? Got a wormhole in it. Maybe that whatever's rolling around on the farm, it'll see apples at all kinds of different angles, so it's okay to rotate it, right? Maybe you're doing this little, I don't know what animal that even is. That thing. If you're trying to look at that thing, right? Maybe it's okay to translate. Those are kind of more canned augmenters that are kind of built into even a lot of APIs that exist for some of these processing machine learning. But spending time on this matters. It shouldn't be something that, okay, let's just an augmentation and bam, let's go. Again, go back to data complexity. You should be spending a lot of time with your data. You should really find ways to make that data meaningful. This is maybe a controversial one, but I can attest to you it works in certain cases. Can you make up data? Can you maybe, again, looking at that balance class, can I make my anomaly, is my anomaly, at least maybe some sense in an image or other kind of structured data, is it reproducible to some degree? Can I statistically potentially reproduce this data to some degree? So in this case, right, take bad apple, maybe I have a good apple, and I can plop it's pretty easy to plop a wormhole looking thing on it. That might skew the distribution, right? So I might want to definitely kind of randomize some things. I might want to change and look at that, what the data looks like. Data synthesis is a real thing, and it can help you solve a problem. You might argue, well, then if you can synthesize it, couldn't you just detect it without machine learning? In some cases you can. In other cases, you can't. So it just depends on the problem type. Spend time with modeling techniques, right? So again, your hyperparameter tuning stuff, your model architecture. Model architecture matters a lot. Learned this a lot with deep learning, okay? Just taking the latest and greatest model from whoever and transferring it and trying to use it. I've not found much success with that approach. Usually the data I'm dealing with is very custom to what I've seen, right? So ImageNet is great and all, but it doesn't really look like wafer images in my mind. So so I have to actually, we train things from scratch because those lower level features in a deep learning problem actually matter. In the case of the data I'm dealing with versus the data that might be in ImageNet. So model architecture matters. Making models too big. This is kind of more, again, I think in my mind, I told you I was going to talk about algorithms, but here I am. I'm talking about it, but these things matter. Yes?
So how do you will select which model are you going to use then?
How do you figure out which model you're going to use? Yeah, so again, without going too deep into the, model and choosing a model, right? Those are things that should be also discussed in the early stages of the data. When you're about collecting the data, what are you going to use to actually measure your model success, right? So there's lots of different ways. It depends on what type of model you're actually building. Are you building a regression model? So maybe mean square error is going to mean square error is going to mean something to you. Are you building a classifier? Oh, what's your problem?
If you will use, if you say, okay, some people use this plugin or whatever, which model you will use or just for your specific data?
So is your question then, to make sure I'm understanding it, how do I know which model to use based on the data? Is that about like model selection? Like what type of model do I use based on the data that I'm being provided? Is that?
For instance, you say usually XBoosting work fine.
Yeah.
Faculty use that type of models and they have success. So for your application, what would be the approach to use? Right.
Okay, yeah. So the question is, how do I know, which model to use? It's very domain specific, and this is where I think a lot of the domain expertise comes in when you talk about data science. I mean, it could be as simple as I take my data and, shove it in a data robot, whatever. It comes out, it tries about 12, 15, 13 different models and says, hey, here's your best one. Pick this thing, right? That's one way. But when it comes down to it, again, I want to say a lot, but I can't spend too much time just because of the IP concerns. So we have a company.
Well, you said model ensembling, so take
Yeah,
a bunch.
try a lot, right? Try a bunch, right?
A bunch and you get the average.
Right, exactly. You do model ensemble, right? You can put it all together, right? You can say model A, B, B, C, D, and you kind of bring it all together, right?
You can see who's mostly right and you can say, oh, maybe I can just get by with that model.
Right, yeah. From a model selection standpoint, again, it comes down to the data type you're using, how big that data is, right? If it's maybe a small data set, maybe an SVM is the right answer, right? If it's a regression problem, it's a classification problem. So, I mean, it comes down to getting familiar with your data, right? And I wish I had a good silver bullet to tell you this is it. I know what we do and what works for us, my company, and a lot of it just comes down to, we know with this data, this is the model that we've gone through enough experimentation hours that we know that this is the type of thing we should use. And this is the scale we should use it at, not just at the normal canned version of it. We should actually change that architecture of that model a little bit because it works better in this light versus that. Does that kind of answer your question? Yeah, a lot of it's just coming from the experience there you're doing. And then, bam, right? So this whole idea of just bringing people into this loop here, bringing humans part of it, you get this, the collaboration is what matters. And I think that's my ultimate value statement there, is if you need to find a way, if you're working with people, get people involved. Like, they need to be intimately involved in this process, and it needs to be easy for them. Make it as easy as you absolutely can, because you're gonna get better success. Right, we just kind of put things in perspective. Because of the system framework that we have, we had a whole new problem come to us about 2 weeks ago that we had to solve. It was a big issue for our manufacturing plant. And we were able to find a great solution within about a week, right? This was and that data set looked like that, right? So you can get there quickly because, again, we had the experience, we had the time with the customers to do a lot of these things to make it work for us. And so, take-home message is try to, when you're doing these problems, build these systems with people in mind, not with your algorithms in mind. Build them first with people in mind, and the rest kind of just falls from there. So that's all I've got. Thank you. Questions? Or appreciate the comments that we did have. It was good. Thanks. Ed.
Yeah, you had to know that. So your talk provoked something I came across a couple months ago, and I sent it off to all my friends, but a way of dealing with small data and putting a human in the loop. And they're calling it reward modeling. So they turn a big data problem into a reinforcement learning problem, except that you're just training the evaluator. And so the example was backflip, not a backflip. Kind of a complex thing to do. I mean, it's a lot more complex than hot dog, no hot dog. And so it starts out, you're supervising and you're training a judge to say, yeah, that was a back. So it's using the open AI gym with their anthropomorphized robots. And so it starts out, doesn't know anything, and so it has these epileptic seizures, and you say, that's not a backflip. But eventually it gets something that looks sort of like it. And pretty soon it's got something that knows kind of backflip, no backflip. But then there's times when it's not sure. So the human can walk away, and it continues to train, and it's training this deep neural net to know this is a better backflip or not a backflip. But when it gets an anomaly, it says, sometimes it's just so, the evaluator will say, hey, I don't know what this is. And it puts the human back in the loop. Help me out here. This is backflip, and then you help it out. So you start handling these edge cases. But you can get by with a whole lot less, humans in the loop, and which is the thing. That's going to take years and millions of iterations, and as a human, you don't want to sit there. So, or you're training the labeler also, and then you don't have to. So if you start training the reward function, that's the way to get by with
Less people.
With less data, yeah.
And small data, yeah.
Yeah, and less people too, right?
Yeah. Yeah. Exactly. Yeah.
So you mentioned like having a modular data layer. I don't really know what that means. So like for us, we have like 1 billion images in S3, and like we have lots of problems that relate to only that one data source. And so we just have like a library that we import that accesses all of that. Can you describe a little bit more what you mean by like modular data layer.
Yeah. So I say modular, in my mind, I think, in the software world, I think microservice. Okay? I think, how do I, if I have data A, data B, data C, they all live in different places, how do I create ways that my team can create easy access to these different data sources and then bring them together into one?
Do you put a server in front of each one?
Well, I don't know what that means. Maybe that does mean that, right? Maybe it just means, do I have a single server and it just has, and I've built my software in such a way that I can access this data ubiquitously, regardless of where it's coming from. So I make a call, comes back, and then it just brings it all back through that call, right? So that's what I'm thinking of modular. Thinking, how can it be plug and play? And then I can create all these base layers, and like a microservice type thing, you can build on top of that. They all become building blocks that I can build. I can take data A and B, I can put them together on top of each other and get, different data here, and even use that design to over here, right? So when I'm talking about modular, I'm talking about that. Go start at the most basic level of access you need to get to your data, and then make it such that you can easily reuse those parts and build on it.
Okay, great.
So, yeah. Question?
Part of me, this is a stupid question, but if I don't understand the human component of the loop, is that a piece of the training of the model that's processing the data? Is the human contributing to the training, or is that, what is the human's actual role in there? Are they just like looking at the data and like, oh, hey, this is cool, let's go do this, right? And there's no feedback there, or what? How does that?
It's a good question. Yeah. So maybe I didn't. I don't think I made the point well enough. Yeah, they're both, right? So a human should be part of this training process, that initial collection of data, right? So again, when they have the problem to you and they have some examples, step one, make it easy for them to get more examples, right? So they can give you that nice starting training set if they can, if it's available. So start there. And then step two, once I've got this feed going and maybe I've got an initial model, it's maybe simple starting point. And this is now, there's some now processing going on. That same human who brought you the problem should now see that data being processed, the predictions, right? If there are predictions, right? However you're using that data, they should be able to see it with the additional structure that you've now added to that data, and be able to provide feedback to that system so that it can continue to learn, right? The active learning component. So does that make sense? So you have the training phase of it, and then you got deployment, and then you've got an active learning component.
As long as
where you're just kind of
collecting data about how the human is using the data, or how the human is interpreting the data to their, to that particular circumstance.
Well, you can always have a change capture on any of your data changes. So for example, if you have a human labeling it and say that you have a labeler labeling it, then the human goes change it, then that's when your change captures kind of come into play and say, oh, we need to update our labeler. Or you go farther down the line and you notice that you're training on a new thing, and you think it's your system would say that's better, go through and deploy it, but then the human comes back in and says, no, there were some anomalies in this data, we need to go retrain. That's also a good option. That's when your change data capture can make a note of that, make note that this batch or whatever wasn't bad, and you can improve your process off of that. So there's lots of ways for the human to be involved.
Absolutely.
In the process, and the way to keep track of it, in my opinion, would be a change data capture or some kind of a store of that.
Make it easy for them. That's the point of that. Make it easy. Might be hard for you to make that system. Make it easy for them because they're the one helping you with that problem. Yeah, Eric.
Yeah, so I mean, we don't have to spend a ton of time on this if we don't want to, but one problem people have with recommender systems is like they want to make a product like Netflix, but of course, like until you get a big user base and people actively using your product, you don't have enough data to even know what to recommend. So like hypothetically, to make this a little more concrete, like say you were going to make a recommender system for a large number of things, like how would you use human in the loop like during training to help with that data sparsity?
During training, right? So again, you get the data, you assume it's flowing in, right, at some point, right? So you can start, it really comes down, it's very custom to the problem you're trying to solve. But you might have to spend a few iterations collecting that data, and that person helping out, labeling that data, before you can actually get to a point where I can take a train model. I can try to at least train something.
What's a person labeling the data? In Netflix, would that be a person watching movies or like?
That would be, yeah, so the Netflix recommender system case, right, it's what are they choosing, right? What is it choosing? So maybe I feel like you're kind of referring to maybe it's just like, if you have an application you're trying to develop, right? I've got X users and number of users, right? And I'm trying to collect their data. How does the human look, right? So they're part of the feed. Those humans are part of the feed there, right? And do you need somebody else then in the loop at that point? I don't know. I don't know if this applies to that problem all the way potentially. You might need some other quality control person, right, that has to look at that data coming in. And there might be some other aspect of the data that you're trying to transfer from this QC person. I don't know if we'll call them the quality control person, looking at the data coming in, making it easy for them. But in that case, the users and those end users are part of your data feed. They're not that human per se.
Gotcha.
The human in the loop in this case would be someone who's actually trying to take that data and do something with it, right? Solve the problem. In this case, it's a recommender system. So and it may be because you already have all these users base, you might not need that person, right? So like I said, this might not apply to every business model you have.
So human in the loop usually refers to like either cleaning data or generating more, something to do with like offline.
Yes.
Modifying the data that you already have. Gotcha.
You're trying to build that data set and expertise into the data because it's something new, something you've unseen. Ed, you had a comment.
Well, I happen to know that with recommender systems, they cheat and they initialize you with the average human to start with. And then over time, you prove that you're not average. But yeah, they cheat. They just totally just drop in. You're average person when you first
Don't we all cheat though?
I mean, that's smart, right? That's a smart way to get your data set on right?
If our goal is to be completely average, we're actually going towards the system and the system isn't fitting to us. We just got meta here, didn't we?
That's what we're talking.
Cool.
Thanks.
Let's give Brian another hand.